welcome. So, we were discussing about salient pole synchronous machine, and I have taken generator mode of operation, and it is supplying lagging power factor angle theta, and I told you how to do it. So, the point is that I am once again stressing this: terminal voltage will be known, armature current will be known, power factor angle, these are known. The question is how to get correctly the position of say q axis. Once you get the position of q axis, d axis position is fixed, it is at right angles to q axis. So, in this last class, this is the diagram with array included. I told you that I did not know the exact position of this one, but I knew this much, that it is generated, therefore, E f must be above E a V. So, somewhere I draw this line and told this must be your delta, and then V I R A plus J I D X D. Then I drew the d axis line, I broke up currents I D, I Q, then add these voltages, you will arrive at E f. But still the point was that exactly where it will be, what is the value of delta. Is it possible from these informations try to get delta from the knowledge of V, I A and theta. Unfortunately, in a synchronous machine you cannot connect an ammeter to record I D and I Q. It is totally conceptual, in our mind it exists. What is there? Which current is flowing in the line? It is I A, and that can be measured. I can measure the terminal voltage, I can measure the power it is delivering. Therefore, it will be necessary to know delta first from this knowledge. That is what I am going to do now. Listen carefully. I will not redraw, because it is already fairly it is drawn correctly. It is like this. Achha. Now, you see, I have to calculate this delta. What is this delta in terms of those quantities and machine parameters? Is not. So, that is what we will do, and we have got I D and I Q. Now, you see that from this tip of this voltage phasor, you drop a perpendicular there. Then I will say this is V D and this length is V q, and V q will be V sin delta, V q will be V sin delta. I am sorry, this is V D, this is V D and this is V q. So, V D is V into sin delta, is not, from this right angle triangles, and this V sin delta, if you drop a line, is this length. This length is V sin delta. Is that clear? So, V sin delta is this length, and this whole length is I q x q. This whole length is I q into x q. So, from I q x q, if I subtract this length, I will get V sin delta. So, V sin delta must be equal to I q x q minus this length. What will be this length? See, angle between I A and this line is psi. So, angle between I A R A is a number, it is parallel to this I A. So, this angle is also psi. This is parallel to this I A parallel to I A. So, this is psi. Therefore, if you drop a perpendicular there, this length will be nothing but I A R A sin psi from this right angle triangle. Okay. Therefore, you take this projection I A R A sin psi and this length is nothing but this length. Therefore, I will say V sin delta is I q x q minus I A R A into sin psi. This must be true. Then the whole idea is this I would like to get rid of the terms involving I q I d from this expression and form a equation from which I will be able to calculate delta, that is the idea. Now, therefore, I will write this in this page only I am writing, although it is becoming somewhat clumsy, but not that clumsy, so that we do not understand. So, what I will do is this, for I q I will put this value in terms of I A. So, this I will write it as I A into cosine delta plus theta into x q x d will be known to me minus I A R A into sin psi. This is so, we come to a fresh page and tell that V sin delta, I rewrite that V sin delta is equal to I q x I A cosine delta plus theta into x q minus I A R A into sin psi, and we know that psi is equal to delta plus theta. So, we expand this term. So, for psi here also I write sin delta plus theta. Now, what all you have to do, a little bit of algebra here, that is you expand those terms. So, V sin delta will be equal to I A, this is I A not I q, I A into x q, that is good, and this you break up into two terms, cos A cos B, then minus I A into x q, sin A sin B, sin A sin B. This will yield two terms and this term also give you two terms. What is that? Minus I A R A sin A cos B. So, cos B sin A cos B plus, that means this minus once again minus I A R A. Oh, okay, sin A cos B minus cos A sin B. So, this will be the thing. Now, what I do? I bring all these sin delta terms, that is this and this, to the left hand side, and I will be getting here V plus I A x q sin theta plus I A R A cos theta whole into sin delta is equal to, these two terms will be there on the right hand side, I rewrite them. So, I a x q cos theta minus I a r a sin theta and whole into cos delta. So, that tan delta will be equal to I a x q cos theta minus I a r a sin theta divided by this whole thing, that is V plus I a x q sin theta plus I a r a cos theta. This is the thing. This will be the expression of tan delta. On the right hand side you see I a, there is no IDIQ, fine, there is only terminal voltage V and there is power factor angle, knowledge of theta is necessary to compute this. Therefore, if I say a salient pole synchronous generator is delivering 10 ampere current at a power factor angle of lagging 30 degree and x d, x q and R a values are these, then I can calculate before starting drawing the Phasor diagram tan delta, hence delta. So, tan delta, tan inverse of that. So, delta will be known from the knowledge of V, I a and theta. And once delta is known, now I will come back to this drawing the Phasor diagram. I will know what is the value of delta, maybe 10 degree, 8 degree, whatever it is. So, after from the operating point I will calculate delta, then I will be doing the Phasor diagram much more confidently now. It is like this. I will sketch V, I a also I can sketch I a, theta, these are the known things, and then R a, x d, x q known. So, calculate tan delta from this expression, delta is known, and then it is generator mode. E f, which is the q axis, must be above V. So, delta known. So, draw a line. Now, delta known, I will write delta here. Of course, I do not know where the C f is, but q axis is now known precisely. I know this is q axis. E f must lie along this line. Then what I am going to do? I will draw a line perpendicular to this here, and I will say this is d axis, where that field poles will be there. Now, theta is known, delta is known. So, psi is also known, delta plus theta. Then you get these two components, and these values are now known in numbers I q. This is psi, this is also psi. Then what I am going to do? To this V, I will say E f will be equal to V, instead of trying to write and V plus I a array, of course, will be, I can take into account I a into array, there is no IDIQ, I a into array plus this drops. IA you now forget, there is difficulty because MA will be along this, we do not know what is the reluctance, it will go on changing. So, I have broken that IA into IDIQ, erase IA from your memory to complete this equation. I will write instead of IA there are two current exists. So, J plus J ID x d, where it will be? It will be perpendicular. IRA first I will add, IRA I will add, IRA. This is IRA. Then I will add to this, this will be parallel to q axis because ID is here. So, J ID x d, and once I get there, then everything is in place. I mean, see, IQ XQ will be J IQ XQ, it brings down this point there, J IQ XQ, and this is J ID XT, and then I will say this is EF. So, in this phasor diagram everything is numbers now. Why? I started with V, IA and theta, then I calculated delta, then I drew the q axis line. Still I did not know where the EF will be, this much, that much, this, that, I did not know, but q axis was drawn properly. So, delta was known, EF, d axis. So, this is IA, psi is known. So, ID is IA sin psi, IA cos psi, like that we will be doing. And note that in this phasor diagram everything is in place. X d is higher than x q. So, this length will be higher than this length, and you get it. If R A is neglected, you can separately find out the expression of tan delta, but in this case put this term will not be then present. If R A is neglected, then tan delta will be equal to I A x q cos theta, that I R A minus I R A cos theta sin theta will vanish, divided by plus V plus I A x q sin theta. This will be the simple expression if you neglect R A, which sometimes people neglect, and then this is the thing. So, this is the phasor diagram of a synchronous generator operating at lagging power factor. I think the synchronous generator operation operating at leading power factor you will be also able to do and find out the expression of delta, you see yourself. But first what I will do, if time permits generator leading power factor also we can do, but I will give you hints. For example, in case of generator leading power factor, I should do then like this. This is V, I will draw. I am just sketching, I will not do any mathematics on this phasor diagram, that is left to you to do. Then I know it is generator. So, EF will be above it. Suppose this is the q axis where your EF will ultimately reside. So, this is this angle is delta, and suppose I say that it is leading power factor. So, suppose the armature current is like this I A. and this is the power factor angle theta. I have just drawn leading, but the moment I got q axis, your d axis will be like this, is not, your d axis will be like this. Oh, I just it has become greater than, I will sketch it. This I a for this thing, it is leading power factor. I will use this one. So, leading, generator leading. So, a typical thing will be, this is V, your E f will be above it. Okay. So, suppose this will be E f, q axis, this will be your d axis, and this is 90 degree, and then this is suppose your I A. Then what I have to do? Then you know this angle is delta, this angle is theta. Then I have to break it up into two components, d axis, that is I d, and this is I q. So, V plus I d x q I will do, this is d I d x d, and then you add V I q x q, V j I q x q to get this value of E f, and IRA drop I have neglected in this diagram, that can be taken into account. So, there are several cases, I hope you will be able to tackle this, but about the motor mode I must do it synchronous. Suppose now I say it is synchronous motor, salient pole, salient synchronous motor, and suppose it is doing drawing lagging power factor current from terminal voltage V. Power factor angle suppose theta. Now, in case of generator, you know, in case of cylindrical machine, I drew it like this, but in this case we cannot draw. So, this is the ZS, but the convention I am trying to reminding you, this is V, this is I A, and this is E f, and we wrote like this, E f is equal to V minus I A Z s, is not, this is the way. Now, see that is fine, but you know human nature, at least for me, addition is much more simpler, is not, things are added, subtraction also easy, but anyway certainly not easier than additions. So, also see that this in case of motor mode, if you start with terminal voltage, in case of cylindrical machine, what I was doing, V, I was drawing current I A, then minus I A R A, minus I A J X S, we were doing getting E f, is not, you recall that. But you could also draw the Phasor diagram saying that okay, this is the voltage equations, which is nothing but this same equation I A Z S you bring there and say that V is equal to E f plus I A Z s. Try to get this point, the same equation I am doing. Then I am arguing that okay, this to draw this Phasor diagram, what you do, you start with E f. Getting the point? Cylindrical machine, this discussion, cylindrical. So, I could also draw this phasor diagram in this way. First draw EF, then say lagging power factor IA is here. Okay. Then to EF add IARA plus IAZS, adding IARA, and you will get terminal voltage. Okay. So, the same phasor diagram, it is now just rotated in space. How does it matter? Without any loss of generality, so that you can quickly draw the phasor diagram. Better draw EF first in motor mode and go on adding drops. Addition is much more, you have to think little to add the vectors. The moment one vector is to be subtracted, okay, where was that vector? Opposite to that you have to do. That is the advantage. Anyway, it is not essential, but I will do like this. So, a salient pole synchronous motor drawing a lagging power factor IA at a terminal voltage V, what will be the thing? So, I know this much only, that in case of motor I know if this is your terminal voltage, EF must lie below it, that is certain, motor mode with this convention. So, EF will be below your voltage. What else are given? You are given IA, but it is a salient pole machine. Therefore, if this is q axis, I will find out d axis here like this, and then I will find out the components of IA in d and q axis, add to EF those drops and get the terminal voltage V. So, in this case I will say that EF must be equal to this thing, that is fine, V minus J I d x d minus J I q x q and minus J I A R A if R A is also present. This is I A, mind you, I A R A. Or I will say V, translating this equation in terms of additions, I will say if you first draw EF, then to EF you just go on adding this J I A R A plus J I d x d plus J I q x q. This is the thing, and this addition thing I will use to relate between V and B EF in the next class. Thank you.